So in this section we are going to study about the hydrograph, a very much important topic in hydrology, and as a civil engineer it is also a very much important topic to study. Okay, so before going into the details of this hydrograph, let us discuss a few points why this the study of this hydrograph is important to us. Okay, so a lot of structures like dams, spillways, bridges are constructed for a particular design life. Okay, suppose we have a river flowing like this. Okay, and this river is coming out of a certain area. Okay, this area, and this whole of the area is contributing water to this river. Okay, whenever the rainfall occurs, then this whole of the area is contributing water to this river. Okay, and we want to design a bridge on this river, or suppose we want to design a dam on this river. Okay, so that we can control the flood, or for any irrigation purpose or any sort of purpose. Okay, we want to construct a dam. So now, before constructing the dam, we should know that how much water is going to be delivered by this stream during the span of years. Okay, so first of all, before designing the structure, we need to calculate what is the maximum amount of the discharge that is going to come in the river or the stream. Okay, so we need to calculate first of all the discharge. Okay, so the design life, what is the design life? Design life is the time for which this structure is going to serve. Okay, so that is termed as design life, and this design life, it is very much important before deciding, before constructing the structure. Okay, because this is the time period for which this structure will be going to serve to us. And for the structures like dams, bridges, the design life should be very accurately measured. Okay, so this is very much important. Now the design life of the structure is dependent upon the discharge, as I have discussed, because they are going to encounter the discharge they are going to encounter during the span of the years. Okay, so we need to first of all calculate the amount of the discharge that is going to come. Okay, because if we don't know exactly what is the amount that is for which, what is the amount of the discharge for which we want to build this structure, so without knowing that discharge, we can't decide the design life of the structure as well as the strength we need to provide to this structure. So that's why this is very much important. So we need to find out the maximum discharge. Okay, so this is the main motive why we are studying this hydrograph. Okay, so to calculate the maximum discharge, to decide the design life of these structures. Okay, so this maximum discharge is calculated by measuring the runoff at the stream gauging station. Okay, so stream gauging station, or it is called the outlet point. Okay, I'm going to discuss in detail. So how this runoff is measured? It is measured by plotting a hydrograph. Okay, so this is the main function. We calculate the maximum discharge, okay, to measure the runoff. Okay, so when we measure the runoff, we calculate the maximum discharge, and this maximum discharge is calculated how? By plotting a hydrograph for the given catchment. Okay, so let us take here is a stream which is flowing like this. Okay, and these are the tributaries of this stream. Okay, and this stream area and its tributaries, these are surrounded by a boundary. Okay, these are enclosed by a boundary. Okay, so this makes a area which is called a catchment area. Okay, or we can term it as basin or a watershed. Okay, so the outer edge of this area, it is called as the ridge line of the catchment. Okay, so this ridge line, it is almost at a higher elevation as compared to the its surrounding points within this catchment. Okay, so the highest point of your any catchment is called a ridge. Okay, so now what happens when the rainfall occurs? Okay, when the rainfall, suppose the rainfall is occurring in this given catchment. Okay, so what will happen, due to the downward slope of this catchment, the water will start to flow from higher elevation towards the lower elevation area. Okay, so the water will start to flow like this, and it will enter into these small channels or tributaries. Okay, and after entering into these tributaries, the water is going to finally discharge it into the mainstream. Okay, so this mainstream is going to take all of the water which is being collected due to the rainfall in the given catchment, and it is going to discharge it to the outlet point of the given catchment. Okay, so the main motive is to calculate the total amount of the discharge at this outlet point. Okay, so this at this outlet point, this stream is going to discharge the total amount of the water that is being collected by the rainfall event. Okay, so in this catchment, so the discharge, it is affected by the rainfall in the catchment and the intensity of rainfall. If the intensity is high, then the discharge is going to be high, and if the intensity is low, then the discharge is going to be low. So we need to calculate there are various methods by which we can calculate the this discharge at this final point. Okay, now the discharge can be measured by several methods. Okay, so we have different methods to calculate the discharge. There is a rational method, there is empirical method, and there is flood frequency method, and we have a hydrograph method. Okay, so depending upon the data which is available, we decide what type of method we are going to opt, whether we are going to use formulas for calculation, empirical method, or we are going to take a practical considerations, or we are going to plot a hydrograph. Okay, so here we are just going to study the this fourth method, that is hydrograph method. Okay, so now to study this hydrograph method, okay, so I have drawn a catchment area here. Okay, you can see this is the ridge line of the catchment, and this is the mainstream, and these are the channels which are contributing to this water to this mainstream, and this is the outlet point where the discharge is to be measured. Okay, so now this hydrograph, okay, so this hydrograph, it directly depend upon first thing is your rainfall. Okay, so whenever the rainfall occurs, okay, within a catchment, then what happens, initially the water which is collected at the ground surface, okay, so there is certain amount of the water that get infiltrated into the ground. Okay, some amount of water get infiltrated, some amount of water get intercepted. Okay, so these are termed as the initial losses after the rainfall occurs within the catchment. Okay, so when these initial losses are met, okay, completely, then your overland flow starts. Okay, so what is overland flow? When these requirements of your initial losses are completely met, then overland flow starts. Okay, so the overland flow takes the water to the streams. Okay, and these streams deliver the water to the outlet point where we calculate the discharge. So here is a small flow diagram for the process. So now let's understand the discharge versus time relationship for this catchment for the given rainfall. Okay, so whenever the rainfall occurs, okay, first of all what is happening, the initial losses are met. Okay, so we are going to take discharge at y-axis and time at x-axis. Okay, now we are also going to take precipitation along with the discharge here. So for instance, let us say the precipitation is occurring for certain time interval. Okay, so let us say that the precipitation has started from here. Okay, so for the given time, the precipitation for a given interval of time, the precipitation is this, and then after that it is increasing, then after that it is increasing, then it is decreasing, then it is decreasing. So this is the rainfall event which is occurring for a given time interval. Okay, so whenever this rainfall occurs in this catchment, so before meeting the initial losses, the water which will be present in this stream, it will be your base flow. Okay, so the base flow, what is the base flow? Base flow is the water which is already present in the stream due to your groundwater flow. Okay, so which is already present before the precipitation within the stream. Okay, so when the rainfall occurs, so this rainfall, this rainfall is going to contribute additional water to this stream. Okay, so we can see here the graph is starting. So the discharge, initially the discharge is like this. Okay, so it has just the base flow contribution at the initial stage when the rainfall has just started. Okay, so when the rainfall reaches to its peak, and the initial losses, that is interception or infiltration, that are completely met, this rainfall is going to contribute to the runoff now. Okay, so this you can see here the discharge is increasing with time now. Okay, because now this rainfall water which is coming as overland flow on the surface of the catchment is contributing to the your discharge. Okay, so the discharge is increasing like this. Okay, so it is reaching at the maximum point, this is called the peak point, and after that the graph is again going down like this, and after all of the water is discharged, then it is going to come back to its initial state, that is the base flow. Okay, so for a given duration of your precipitation, okay, so the discharge is increasing, it is reaching its peak value, and after that it is decreasing. Okay, so this plot, so this plot is called a hydrograph. Okay, so what we are plotting here, we are plotting discharge versus time for a given storm event. Okay, you can see here the peak of the rainfall event and the peak of this discharge, they are lagging through some time. Okay, so this time by which this peak of this discharge and the peak of your rainfall event, they get lag, this time is called the lag time. Okay, why this is occurring? Because whenever the rainfall event occurs, there is no suddenly the water in the river is not going to rise. Okay, so it is going to take some time to rise, then it is going to reach to its peak value, and after that it is going to decline. Okay, so this is called the lag time. Okay, the peak of it is the peak of your rainfall and the peak of your discharge. So this is this distance. So now let us discuss the hydrograph in detail. So for reference, I have drawn a hydrograph here for a given duration of rainfall. Okay, so let us consider a concentrated storm producing a fairly uniform, that is a uniform rainfall of duration capital D. Okay, so here what we are taking the depth of the rainfall to be uniform. Okay, so we are not taking here the depth to be non-uniform, as I discussed earlier when we discussed that the precipitation is starting from here, it is increasing for certain duration, and then it is increasing like this, reaching to its peak, after that decreasing, and then decreasing, and finally stopping. So this is the duration for which the rainfall event is occurring. Okay, so now this for this duration D, what we are assuming here, we are taking the average of this all rainfall depth here. Okay, so let us take that the this rainfall is occurring uniformly. Okay, so the depth we are taking is the uniform depth of the rainfall to reduce the complexity in understanding the hydrology concept. Okay, so now when the initial losses, after the initial losses and infiltration losses are met, the rainfall excess reaches the stream through the overland channel, and it starts to contribute towards the discharge here. Okay, so you can see here at the initial stage, the discharge in the stream is represented by MA. Okay, so this is due to the this discharge is due to the your underground water flow into the stream. Okay, so there is no any contribution of rainfall till now. Okay, even the rainfall has started. Okay, so what is happening at the initial stage, the water which is coming on the land surface due to this rainfall, it is getting intercepted as well as infiltrated in the ground surface. So these are termed as the initial loss, and as a result of this, the discharge in the stream is at the initial stage, it is not increasing. But after your initial losses are completely met, okay, then the runoff in the stream is starting to rise. So you can see here from A to B, the graph is increasing. Okay, it is increasing certainly. Okay, now this AB section, it is called the rising limb of the hydrograph. Okay, so now after that this discharge reaches to its peak value. Okay, so when it reaches to its peak value, so this point, this P point is called the peak value of the hydrograph. Okay, now this B and C point, these are called crest segments. Okay, so why this is your crest segment, because the hydrograph is changing its shape from these 2 points. Okay, so this BC segment is the peak segment, and this is very much important for hydrologists. Okay, so this section, this BPC. Now after reaching the peak point, this graph is declining like this and reaching to the initial base flow. Okay, so now here you can see there is a time lag between the occurrence of the rainfall in the basin and the time when that water passes the gauging station at the basin outlet. Okay, so the runoff measured at the stream gauging station will give a hydrograph, which is shown like this. Okay, so the duration of the rainfall is also marked in the figure here to indicate the time lag in the rainfall and runoff. Okay, so now the hydrograph of this kind is called a flood hydrograph. Okay, so it has three characteristic regions. First one is your rising limb, that is AB, point is joining point A to B. Okay, and then there is another segment, that is BC. This is called your crest segment, and after that we have a falling limb, that is CD. Okay, so this is the hydrograph for a storm. Okay, so now B and C are called the inflection points because hydrograph is changing its shape from at these points B and C. Okay, now let us discuss the components of the hydrograph. Okay, so here we have three segments of hydrograph, that is your rising limb, then your crest segment, then the falling limb. Okay, so we'll start from the rising limb. So you can see here this rising limb is also called as the concentration curve. Okay, this is representing the rising your gradual building up of the storage in the channel, okay, over the catchment surface. Okay, so this limb is showing like this. Okay, so now let us take this here. This is a catchment. Okay, this is your stream, and these are the your contributing stream. Okay, so now when the initial losses and your infiltration losses made, okay, during the earlier period of the storm, then this during the earlier period of the storm, it causes the discharge in the stream to rise rather slowly in the initial period when the your stream rainfall is just occurring. Okay, so as your storm continues, more and more flow, as the storm continues, then more and more flow from distant parts of this catchment, okay, that it reaches to the basin outlet. Okay, so your water is finally reaching at this outlet point after certain time duration. Okay, so now simultaneously the infiltration losses also decreases with time. Okay, so thus under a uniform storm over the catchment, the runoff increases rapidly with time as indicated by this. Okay, and in the basin and the storm characteristics control the shape of this rising limb in the hydrograph. Okay, now second one is your crest segment, that is the BC segment. Okay, so the peak flow occurs when the runoff from various parts of the catchment, catchments simultaneously contribute to achieve the maximum amount of the flow at the basin outlet. Okay, so generally for your large catchments, this peak reaches after after some of the duration has been passed. Okay, so because this hydrograph we are plotting, it is plotting at this outlet point of the catchment, and storm might be occurring at here at this point, or somewhere here. Okay, so we don't know where is the exact location of your storm. Okay, so there might be certain distance, certain time lag between the precipitation point and the outlet point. Okay, so this is called as lag time. Okay, now moving forward, we have third part of this hydrograph, that is the falling limb, that is represented by CD. Okay, now this recession limb, it is which extends from the point of inflection at the end of the crest segment to the commencement of natural groundwater flow, that is D. It represents the withdrawal of the water from the storage, okay, built up in the basin during the earlier phases of the hydrograph. Okay, so in this section, that is CD section, the withdrawal of the water which has been collected due to this rainfall in the basin has started. Okay, so it finally reaches to the point D, okay, to the base flow. So these are the some of the important points regarding the components of your hydrograph. Let us take the factors, okay, that affects the hydrograph. Okay, so the factors that affect the shape of the hydrograph, that can be broadly grouped into your climatic factors and your physiographic factors. Okay, now physiographic factors, it contains your basin characteristics like shape, size, slope, etc. Okay, so these are your physiographic characteristics. And what is the climatic characteristic? Climatic characteristic is the intensity and the duration of the storm and the location of the storm. These comes under your climatic factors. Okay, so first of all, let us discuss the first point in the physiographic factor, that is the shape. Okay, so here I have drawn 3 different hydrographs for different shapes of your catchments. So in the first hydrograph, you can see that the hydrograph is skewed left. Okay, so the peak is reaching at the earlier stages. So peak occurs relatively quick in this case. Okay, so why this is happening? Because whenever the rainfall will occur in this type of catchment, it will start to contribute very quickly to the mainstream, and it will reach at the outlet point very quickly. Okay, hence we are going to get this peak at a very early stages. Okay, so we can see here that this portion it is narrow, and at this portion it is wide. So at the outlet station where we are going to measure the discharge, the water is reaching quickly, so we are going to get the peak relatively quick. Okay, so there will be less lag. Lag means time to reach from here, the storm if occurring here, then the time to reach water from here to here, this will reach very quickly in this type of basin. Okay, so in second type of basin, you can see this is your skewed right. Okay, so this is your right skewed hydrograph, where the peak is occurring at a very at a large distance. Okay, so the lag is more. Okay, and why this is happening? Because this is at from the various parts of the catchment, the water will reach to this mainstream, and after that it will reach to the outlet point, and it will take a lot of time. Okay, so the time duration will be more in case of this type of your catchment. Okay, so now in the third type, it is a very complex hydrograph. So you can see here we are having 2 peaks. Okay, so because the shape of this this catchment, the shape of this catchment is like this. Okay, so what we are going to get the peak flow first at this stage, and then the peak at this stage. Okay, so this is your complex hydrograph for complex shapes. Okay, now next one is your size of the basin. Okay, so if the bigger the basin, then higher peak. Okay, the more water will fall to the catchment. If the basin is bigger, then more water will fall to the catchment, and the base time is more. Okay, so what is the base time? Base time is from here to here. This is called the base time. Okay, so the base time will be more if the size of the basin is large. Okay, so the water will take time to reach the outlet point. Okay, so this is the size of the basin. So if the size is small, then there will be less water reaching at the outlet, and your peak will be small, and your base time will also be small. Okay, now third one is the slope. Now slope, if the slope is very high, so if this is your catchment, and if the slope of the catchment, that is the elevation, is very steep, okay, from ridge to the valley face, okay, where the stream is there. So now if the slope is very steep, then the water is going to move very quickly towards the stream, and it is going to reach to the outlet point very quickly. So water will quickly reach the stream, and the lag time will be small. Okay, the lag time on the time duration from here to here, it will be very small, and the peak will be high. Okay, similarly, if the slope will be less, then water will take time to reach at the outlet point, and the lag time will be large, and the peak will be small. Okay, so now the large drainage density, this is the main next point. Now drainage density, what is drainage density? It is the total channel length divided by the total drainage area. Okay, so if higher is the drainage density, okay, if the drainage density is your very much higher, then water will reach quickly at the outlet point, resulting in your higher peak. Okay, if your drainage density is your lower, then the lag time will be more. Okay, so this is your drainage density, right? What drainage density means, if this is a catchment and this is your stream, and this suppose we are having only this much of your contributing stream, and we have another catchment, and here the size of the catchment is same, but your contributing streams are more in number. So the drainage density here is large as compared to this. Okay, so we have number of streams are very much large. So if in this case your water will reach quickly at the outlet point, and it will result in higher peak. Okay, so now next one is your land use. Okay, so if land use is also a very much important factor, because if there is a forest land, then there will be more interception, so more evaporation will occur, and it will result in lower peak. Okay, so lower runoff volume will be achieved, okay, at the outlet of the your basin. Now if the opposite of this happens, if the land with less vegetal covers, then your interception will be less, and it will result in large peak values, okay, and larger runoff volume. Now another one is your climatic factor. These factors are intensity, duration, and direction of the storm, and location of the storm. Okay, so if the intensity of the rainfall is more, then for the fixed duration, it will result in a higher peak. Okay, so and if the intensity is fixed, duration is increased, then the peak increases with the duration. Okay, and if duration is sufficient, then whatever the water is falling, it will convert into the runoff. Okay, so because all the infiltration will be over. Okay, so peak is then found out by I into A, that is infiltration multiplied by area. Okay, sorry, I is the intensity multiplied by area. Okay, so this is how your intensity plays an important role. So higher the intensity, if the intensity of rainfall will be higher, automatically your runoff will be higher, resulting runoff will be higher. So there is direct or relationship between the intensity and your runoff in the catchment. Now last one is your location of the storm, or location of the storm means as I discussed, if this is your catchment, okay, and this is the stream, okay, and these are the contributing streams, and this is the outlet point. So if the location of your storm is here, for instance, say, okay, so the water will take time to reach to the outlet point, okay, so there will be more lag, or there will be time lag between this, and it will result into your it will result in higher peak values, okay, sorry, lower peak values if your the location of the storm is far from the outlet point. If the location is near to the outlet point, then it will contribute too quickly to the stream, and it will reach at the outlet point very fast. Time lag will be slow, less, and peak will be high. Okay, so direction of storm is also there. If this storm is moving from downstream to upstream, okay, if it is moving from downstream to upstream, then a lower peak will exist, okay, and high lag time will be there, okay, if it is moving from here to sorry, downstream to upstream, and vice versa, if it is moving from upstream to downstream, then the reverse will occur. Okay, so these were the points, and these were the important factors that affect the shape of this hydrograph. Okay, so what is important here, the important thing is that you should understand why we plot the hydrograph and what are the important components which are there in the hydrograph. Okay, so in the next class we are going to study about the unit hydrograph. Okay, thank you so much.